Now I want to move on to talking about some of the details of how data gets used. So we'll move away from what do we store and move into how can we make our information most useful to us as people get it and use it and provide information back to us. So if you have a database that has information that is being exported either to GBIF or to some other place, then what happens to it, how does it get used, and what information can you expect to receive back about it? So that's what we're talking about here. It's about identifying objects in ways that, well, we'll see, and how this feeds into the semantic web. So we're starting out by talking about identification, establishing identifiers of things. And what that means and why we do it is the way we start. I want to talk a little bit about some identifiers that you're very familiar with because they're used in everyday life. It's not a biodiversity example. And then start to talk about the details, resolution, uniqueness, etc. And so we'll see. So this seems simple. An identifier is a string. It's a bunch of characters linked together. You change any of the characters, it's a different identifier. Okay, you put a pound sign on the end or add a dot, it changes. It's a different thing. So it really is just a specific string, a bunch of letters together. That's all that means. But what we do is we then attach that as the name of some specific thing. And we're going to talk about things that, characteristics of identifiers that are particularly useful and important. And one is persistence. So if you attach an identifier to a thing, you can't turn around later and use that same identifier for a different thing. So you attach an identifier to something, that something disappears, it's no longer available, so you say, well, in that case, I'll just use this for something else. That's not allowed. Once something's been identified forever, that identifier is taken and can't be reused. So we don't reuse them. Unique means that within some particular community, this identifier is only used for a single thing. It's almost the same thing, but now we're really saying that if I have an object and I put an identifier on it, and you have an object and you put an identifier object on it, we don't choose the same identifiers. And we'll talk about how that works, how you can enforce such a thing. So for instance, if an identifier is simple as a number, chances are it's not going to be unique because different people are going to use the same number over and over. Like object number 1. Pretty good chance that there's another object number 1 someplace else. So, and again, it's important that within a community of use, we get uniqueness. People talk about globally unique as though we're going to be able to enforce that nobody else will ever use this same exact identifier for any purpose whatsoever. But it turns out we don't really care that much about that. What we really care about is that within the biodiversity community, if we get our hands on an identifier, it's unique. It's not used for two different things. We'll be more specific about that later. One of the very important points is that if we get information associated with an identifier, so it says this identifier has properties, or the object has properties, and somebody else, we get from someplace else, another set of properties associated with that identifier, then we can say all of those are about the same thing. So the identification allows us to aggregate. So if we send out an object and we put an identifier on it, and somebody sends us back a commentary and it says, this commentary is about this identifier, then we know that it's about the same object as the data we send out. So you send data out, you get feedback back, you make the connection between the data you export and the feedback you import by the identifier. Okay, so that's the sense in which it allows aggregation. You get information from different places carrying the same identifier, you know that it's about the same thing. That's what's so important about identifiers. And I guess that's a little different from keeping a catalog of museum specimens. Catalog of museum specimens, the purpose of that kind of identification is different from the identification that you do when you export data from the museum. Now also, identifiers support services. By that I mean that if you have an identifier that comes from a certain domain, like biodiversity, then you can expect to be able to present that identifier to some service and find out stuff about it. So that when a community adopts identifier strategy, usually what they do is they say the identifiers have to have one of these forms, but also all of these identifiers will support a certain collection of standard things you can do when you get an identifier. So if I get an identifier, I can present it to GBIF and say, do you have any data about this identifier? And GBIF will come back and tell you if they have that or not. I'm not saying GBIF does that, that's the idea. So if you have an identifier of a taxon, you can present that identifier to a name service and find out a classification of the taxon. That would be a service that would be available for taxon identifiers if we had a taxon identification service. Paco is sighing because we wish we had such a thing for many years. And so I'm going to show you some examples of identifiers adopted by communities that support services. Okay? So I start with retail. So there's a familiar identifier, right? Okay, but it's a specific kind of barcode, actually. It's a product, it's a universal product code, a UPC code. How do I know it's a UPC code? Because I know it's a UPC code, because I'm the one who created it. Whether you could look at it and tell from it that it's a UPC code, I doubt it. But I made it. I mean, I got the picture. I took a picture of a barcode that was a UPC barcode, so I know it is. Now, okay, so let me see what I have on my notes here. All right. Okay. So we're going to look at UPC, and DOI is another one. So if you read about what the community of merchants, I don't know who exactly had created this strategy, but it's a strategy that is adopted by a community. They have an organization that manages these things, and it's a symbology. It's a way of presenting an identifier. It's not just the identifier, not just those numbers, but it's actually a way of presenting those numbers using a barcode. And the reason that's very important is because barcode scanners rely on it being presented in a certain way. If you presented it with a different style of barcode, with a QR code, for instance, it wouldn't be a UPC anymore, because that's not what they are. They're barcodes in a particular style. And there's an international standard of these things, and there's registration and there's allocation. So this organization allocates blocks of barcode values to different manufacturers, and they put them on products, and then the products are recognizable because of the barcode, right? Now, services are associated with these things. Here's actually a bigger picture of that barcode. So I cut the barcode part of it, the UPC, out. And I don't know if any of you have seen these kinds of things, whether they do this everywhere. Anybody know what this is? You know what Ralph's is? No, Ralph's is a grocery store. And this is the customer identification from that grocery store. So you go in and you become a customer, they give you a credit card size ID, and they give you these smaller ones that you can put on your keychain. And so people have big blobs of these on their keychains. They go into a store, you scan it at the cash register, they keep track of everything you ever bought. I mean, they give you services. And one of the services is, if these lost keys are found, please return to the nearest Ralph's store. So that's a service associated with the use of this code. So I suppose that, in fact, this thing that I've shown you and I claimed was a UPC code isn't actually a UPC code at all, because it came off of this other kind of thing. And I'll show you a real UPC in just a minute. I hadn't realized that until just now, that I was lying to you about this being UPC. But it turns out that these numbers also are nationwide allocated in the US, and that even though I got this one from Ralph's, I can take it to some other store and I can still use it. Because the company that manages these customer identification is actually not the grocery store chain. It's a bigger, so they buy into, so you might not be able to take it to any store because there's multiple competing companies, but you can take one that you got from this hardware store and take it to a different hardware store and it'll still work, even though it's not theirs, right? They'll still scan it, it'll still work. And also you can use this when you go to their site you get your rewards. Now I'll show you a UPC, retail UPC. Here is a picture of scanning an item at a store that has a cost scanner. So you can pick up any item in the store and you can stick it under this, it'll tell you how much it costs. And so this says that it's, I don't know, it's t-shirts for babies and it's $9.99. And that's all it's just scanning the barcode. So there's a service that's provided by the store to map the UPC into price. Okay? And if, anyway, so that they have some services. Now notice that the UPC doesn't identify this specific bag of t-shirts. It identifies the product. All of the bags of t-shirts that are what considered to be the same product. The bags may be different, the printing may be different on the bag, but it's going to be this quantity of this kind of shirt every time. It does not identify that bag. So as far as specimen identifiers go, this is not the kind of thing we want, right? We don't want to identify all of the specimens in the museum. Anyway, we probably need something other than UPC. Information architecture refers to what you can do with the information that you have. How do you store it, and what services are available for it. So the company uses it to track the manufacturing process. They use it to track the packaging. They use it to track sales, right? The store uses it for inventory. They use it for sales. So the different users of this treat it differently. The store doesn't use it to track manufacturing, right? But the manufacturer knows that when these t-shirts are being printed, are being created and packaged, that's associated with this particular product. And they track the product with the UPC. But sometimes you have more detail you need than just the product. So I have another one here. This is a real barcode. Where is it? There it is. Okay. So this guy here, that thing on the bottom, that's really a UPC. That's what they look like. They have a, no, it's not just a simple barcode. It has this structure. The numbers on the ends are pulled out, and et cetera. That's what a UPC really looks like. The barcode above it is not a UPC. It looks like it's a lot number. This is actually a box of contact lenses. So with a box of contact lenses, they need to, the barcode, the UPC code identifies the strength and the curvature and the product line and all of that. It's all we care about as a consumer. But when they want to track, like, was there a problem? Do we need to do a recall, etc., they manufacture in lots, and they put the lot identifier on the box as well. So they get a little more information. They go beyond the UPC and add a little bit of extra. So it doesn't even for the manufacturing community and the retail community, UPC is not sufficient. It only does a very small amount of stuff. So you have an identifier strategy. It does some particular collection of things, and that's all. Now, a digital object identifier is being used by the publishing industry for publications. And they put an identifier on an object. And they have services. Like, you can present this object identifier to a website, and it will it will take you to the publisher's page for that publication. So if you publish an article in a journal, that article gets a DOI, and if you put the DOI into a browser in the right form, you get back the web page for the journal. So resolution is very important. That is, you can take this thing and you can give it to a web service and it can tell you something about it. And that's because because DOI is not just a collection of identifiers, it's also a commitment to services. Now, the reason that the commitment to services works is because the publishers pay for the identifiers. So if you're a publisher and you want to issue identifiers, you pay the organization for the right to issue the identifiers. And the organization, in turn, maintains those identifiers for you and the mappings to web pages and things like that. So there's this web service, dx.doi.org, and you might be able to go there and get some metadata, like what's the title of the article and what's the volume number, things like that. Now, this is me scanning the contact lens code at the store. They have no idea what it is. They don't know that. They're not committed to keeping track of all the UPCs, only the ones that they sell. They don't sell this, they don't care. So it just says item not found. It doesn't tell me, it doesn't say, if you want to find out more about this, go here. Because their service ends with what they have in the store. So the point is that we produce limited capabilities that are specific to purpose. You have some purpose, you build things to achieve that purpose, and you stop and you refuse to do other things. So this particular store doesn't want to tell me that that's a contact lens. They could go on the web and look it up and come back and say, oh yeah, that's this contact lens. But they have no commitment to do that, and they only want to show you the price in the store. Why would they do more? So you can't generally get information about UPC from the price scanners in the store. They only do price scanning of the stuff in the store. There is a strategy that has been promoted in the web that is called linked data. Linked data, so it's semantic web, which means data with meaning. So not just web pages, but ways of establishing more detail. If you look at a web page, we as humans can understand what's on the web page. Computers have a lot of trouble. They don't recognize we know that when people present information to us, they emphasize certain things and de-emphasize other things by the way it's presented visually. And we know how to recognize advertising and ignore it. Right? We're very good at ignoring advertising on web pages. Web pages filled with advertising, we look for the stuff that's not advertising. You can imagine that a search tool or a web page analysis tool would have a lot more trouble figuring out what things were going to jump out to the eye. That is the most important part of the page, and what is unimportant. So the idea of the semantic web is to have providers give the essence of the information of the page in another form, which can be easily consumed by other systems. So the key technologies. URI. It means Universal Resource Identifier. It's different from URL, Universal Resource Locator. Now, some URIs use HTTP. So you have something called an HTTP URI, which seems a lot like a URL. What's the distinction? Well, one distinction is that a URL has a very specific form. Typically it says HTTP, it doesn't have to, but HTTP and then a domain name and a couple of slashes and a bunch of other stuff. Whereas in the case of URI, there are a lot of different forms that it can take. Doesn't have to be, but what people who worry about what things mean want to distinguish between where you go to get information, which is a location, and what the information is about, which is an identifier. So there are certain strings which function as both identifier and location, and an HTTP URI would be such a thing. So sometimes, with certain kinds of identifiers, you can paste the identifier into the address field of a web browser and get directed to a web page. And one of the nice things about the linked data is sometimes you can take that same HTTP string and you can request something different, not HTML, and get back a better presentation. And what the semantic web or linked data relies on is this technology of RDF. And RDF stands for something. I think I have it later what it really stands for. Something. Resource Description Framework, I think. So it's a way of presenting information that is semantically accessible. It's more like objects and properties than it is web page. So if the identifier of an object is an HTTP URI, you might be able to actually go to there and get back some interesting data. And linked data relies on that. So if you go to a big linked data site like DBpedia, DBpedia is the linked data version. It's the database version of Wikipedia, in which information is presented in more of a database style in RDF. So DBpedia, you can go there and get this more primitive form of the information in Wikipedia, not presented as text, but as structured data. So linked data supports URIs, which are identifiers, HTTP, which is a resolution and information access protocol, and RDF, which is the way that information is exported and ingested by an agent. So the idea is that you could have a computer program or an agent which goes out asking websites for RDF and then getting in the RDF and making inferences and aggregations and other things based on the information they get. And so this is where the real power of all of these tools come together. You have the identification plus the data and the properties all being presented in a way that's meaningful. So that's what semantic web is all about. That's what linked data is all about. And to a certain extent, our goal a goal of making information exportable is to allow it to be exported in this exact form. So not just generally, but specifically using these protocols, making information available. Okay, so time for another. This one's simpler. So the idea is to go back and see what you've got. Look at this data and see where you see identification coming out. In MorphBank, for instance, you'll see. Let me go to. There's a string right here. 791407. That's a unique number within the MorphBank system that identifies this object. It's not globally unique, but within MorphBank, it's unique. So that's a kind of an identifier. It only works inside. But if you look up here, that's another, maybe that's an identifier, where it says MorphBank and then it says $ID equals number. Or maybe it just says MorphBank / number. And those are possible identifications of the object, because we use that number as our identification. So you'll see this. Sometimes you'll see LSID. That's a strategy for identification that a lot of people are using in the biodiversity community. So what I'd like you to do is just go back to those things you were looking for and see if you can, you were already looking at, and see if you can find any identification on those pages. Okay, what is being identified? On the MorphBank page, there's several things being identified. There's, in this case, this is what, an image? This is an image. It's image number. See, we put it right up there. That's the image number. But it also is a specimen. It's related to a specimen. There's a specimen number. And there's a locality number. And there's a view number. It's a whole lot of identifiers in there in that particular page. Okay?
Thank you. Bueno, entonces, como Greg les ha estado diciendo, entonces nosotros usamos los identificadores persistentes para identificar, digámoslo así, objetos, personas, recursos de una manera única. Entonces, esta publicación SUKIS, que muchos de ustedes la conocen, que es del grupo Pensoft, que también tiene otra publicación que se llama PhytoKIS, y tiene otra que es especializada en hongos, que se me olvida ahora el nombre, es MycoKIS. Y están por implementar otra publicación especializada que se llama Biodiversity Database. Bueno, ellos han implementado en sus publicaciones, han implementado esto de los identificadores persistentes, y quiero mostrarles un artículo donde podemos encontrar identificadores persistentes para diferentes objetos, personas o conceptos. Entonces vamos a ver, este es uno de los el último artículo que salió en PhytoKIS, y fíjense ustedes, estos identificadores únicos que están acá, que son estos, ¿cierto? Que son un código, digamos, alfanumérico único que distingue, en este caso, distingue a cada uno de estos autores. Fíjense que aquí está la cruz y esta es la cruz. Y ahorita vamos digamos, a resolver, lo que decimos resolver, el identificador persistente, que es ir a la información que está identificando ese identificador. Entonces, si damos clic aquí, fíjense acá, es Lin Yang. Entonces voy a ir al identificador persistente del autor y él me manda directamente a una, digámoslo así, a una base de datos de investigadores que se llama el SUBANK. Y ahí pues me da información acerca de ese autor en especial. Nombre, apellido, bueno, aquí las publicaciones, aquí pues está bastante simple, pero puede ser el caso que, pues eso depende de qué tanto uno quiera dar información o qué tanta información le requiera digamos, la base de datos. Bueno, entonces fíjense que llevamos el primer ejemplo, un identificador persistente para un autor. También tenemos el identificador persistente para el artículo, que es el DOI, el que está acá. Que ustedes saben que el DOI es el identificador único y persistente que identifica ese artículo dentro del grupo de todas las publicaciones a nivel global. Además, en esta misma publicación tenemos otros identificadores persistentes. Fíjense en este. Este es un género y también tiene su identificador persistente, que sería este. Vamos a ir allá. Entonces, el identificador persistente está identificando ese género y lo que nosotros llamamos resolverlo es simplemente ir a la fuente de la información, por decirlo así, simplemente, llanamente. Entonces aquí podemos encontrar toda la información relacionada con ese género. Entonces fíjense que ya llevamos 3 identificadores persistentes en la misma publicación. El DOI, que identifica el artículo, el identificador persistente para el autor y el identificador persistente para uno de los taxones que está involucrado en la publicación. Vamos a ver si hay uno de pronto para especies. Sí, aquí está. Entonces funciona más o menos igual. Yo doy clic ahí, él me va a llevar a la fuente de la información, que en este caso es la misma fuente de información del género. Pero fíjense que A pesar de que es la misma publicación, yo tengo varios tipos diferentes de identificadores persistentes que al resolverlos me llevan a diferentes fuentes de información. Por un lado me puede llevar con el DOI, puedo ir a las fuentes de información bibliográficas. Por otro lado, con el identificador persistente de los autores, puedo ir a las fuentes de información donde están registradas la información de los autores. Y por otro lado, puedo ir con los identificadores persistentes donde están las fuentes de información de los taxones que están relacionados. Ahora, yo podría tener un identificador persistente, en este caso no lo hay, pero yo podría tener un identificador persistente también para cada una de las imágenes. O para cada uno de los especímenes que está involucrado en la publicación. ¿Sí?